Assalamu alaikum. My name is Ahmed and my registration number is 2018042 and I am going to discuss CP project of the course ME315. So first of all, I am going to discuss briefly about car suspension system. Drivers of the vehicles are at high risk of developing serious health disorders due to prolonged exposure to high vibrations. So we have to work closely on suspension system to reduce vibration. So in this presentation, we will closely analyze the frequency response with respect to the time. So the project objective is to model a car suspension system. The car is passing over a disturbance of the amplitude 0.01 meter in our case, and we have to incorporate the following conditions that we have to use 1 degree of freedom of system, the moving mass of the system, and the excitation of the base. Now the next step is to discuss roadmap profile. The given roadmap profile is of sine wave form, and the amplitude of the roadmap profile is 10 millimeter and the sine wavelength is 6 meter. So for solving various equations, we need some of the parameters. Number one is spring stiffness, damping coefficient, and the mass. So I have accessed the results of the report. I have also attached the link of the report as you can see here. The next step is to calculate the frequencies and damping ratio. I have calculated natural frequency, base frequency, damped frequency, and the damping ratio as you can see in this figure. Now coming towards the derivation for car suspension system. According to Newton's second law of motion, sum of all forces is equal to the mass times acceleration of the car. So there are three types of forces acting on the car. Number one is its weight, number two is the spring force, and number three is the damping force. So I have incorporated all these values in this equation. I have ignored the weight due to static equilibrium. So the equation can be written as you can see here. I have assumed the value of the form yt is equal to y sine omega t. So I have inserted this value into this equation and my new equation becomes like this. Now in the next step, I have converted this equation in the form of the natural frequency as you can see here. So as you can see that on the left hand side there are two terms, so we have to assume two particular solutions. One particular solution is in the form of cosine and the other particular solution will be of the form sine. Now before solving particular solution, we will first solve the correct equation. We will use the equation as you can see here. We will find the value of the constant a1 and a2. Then we will use this equation to find the value of x homogeneous. We will put the values of a1 and a2 and then we have this answer where k is the constant. Now I will find the first particular solution. So for solving first particular solution, I have assumed the solution of the form x cos omega t minus theta. I can also write this equation into this form by using this triangular relationship. Then I will only assume one term on the left hand side. I will plug in the value of x into this equation. So I have this equation. Then I have compared the coefficients of sine and cosine to find the values of the constant as and bs. So in the next slide I have calculated the value of as and bs as you can see here. Then by using Pythagoras theorem I have found the value of x. Then using the trigonometric relation I have also found the value of theta 1 as you can see here. Then finally I have plugged the values of x and theta back into the first equation. So I have the first particular solution will be of the form like this. Now for the second particular solution, we will follow the same procedure as we have followed for the first particular solution. But in this case, we will assume the particular solution of the form x sine omega t minus theta. And we will consider the other term on the left hand side that we haven't used previously for the first particular solution. Then we will plug in this value of xp2 in this equation, and then again we will compare the coefficients of sine and cosine as you can see here, and then we have found the values of as and bs as you can see here. And then using Pythagoras relation as I did for the first particular solution, I found the value of x. Likewise I found the value of theta 1, and then plug it back into the xp2 equation. So I have the second particular solution will be of the form as you can see here. Now the particular solution is the sum of first particular solution and the second particular solution. I have just plugged in the values of first particular solution and the second particular solution as you can see here, and you can see that I have written these two equations into a single equation by utilizing this triangular relationship and introducing one new angle theta 2. So our final particular solution will be of the form you can see here, and the second angle will be tan inverse omega n divided by 2 into damping ratio. So the final solution will be the sum of the homogeneous solution and the particular solution. I have just plugged in these values, and this is our final solution. Now the next step is to code using MATLAB software. I have written all the expressions as you can see here, and then I have found the value of k and beta by utilizing these expressions. And lastly, I have plotted the response of x with respect to the time by writing this code. Now lastly, I am going to discuss the result. As you can see here that the first part of the graph is deviating. It is due to the transient behavior, but the rest of the part is homogeneous. And the response of the graph is highly dependent on the values of C, M and K. So that's it. That's all from my side.